Okay, so here we're going to look at some exact values of sine and cos. So I'm going to show you the sine and cos graphs and some triangles, which will help you remember the values of sine and cos for 0, 30, 45, 60, and 90. So the sine graph first. So it starts at 0. It starts down here, and what we do is we go up to 1, down to 180, at 270 we go to -1, and back up to 360. I mean, not the perfect drawing, but it's a nice wave shape. Cos graph is the same kind of shape, but instead of starting at 0 we start at 1 and we go down to 90, through 180 at -1, up to 270, and we finish back at 1. So they're the sine and cos graphs. So from this, we can look at the values of sine and cos for 0. So at 0, sine 0, so sine of 0 degrees, sine of 0 equals 0, and cos 0 equals 1. And at 90, we've got sine 90 is at 1. Sine 90 is 1, and cos 90 is at 0. You should know the shapes of these graphs, and you should be able to sketch these graphs. So you should know that sine starts at 0, goes up and then down, and cos starts at 1 and follows the same shape but shifted over. So what we're going to do is we're going to look at these two triangles. So here I've got an equilateral triangle, so each side's the same, so each side's 2, and I've got a right angle triangle, a right angled isosceles triangle, so these two lengths are equal and they're both 1. So we're going to look at that. So what we're going to do is we're going to cut this shape down the middle. So at the moment all the angles are 60 degrees, and I'm going to cut it straight down the middle. So I'm going to have a 90-degree angle here. So this is still 60. This one's cut down the middle, so it's 30. Instead of 2 for the whole length, I'm going to rub that out. I'm going to have 1 for half the length. And these two angles here are 45 degrees, because they're at the base of an isosceles triangle. So the next thing we've got to do is we're going to work out these missing lengths, the lengths we don't know. We're going to use Pythagoras. So here we've got this side, so let's call it x while we work it out. X squared plus 1 squared equals 2 squared. So x squared plus 1 equals 4. X squared equals 3. So x is root 3. So this length here is root 3. And here we've got 1 squared plus 1 squared equals x squared. So 1 plus 1 is 2 is x squared. So x is root 2. So this is root 2 and this is root 3. And then from these we can work out any values of sine and cos for 30, 45 and 60. So if we look at this angle here, 30 degrees, we know that sine of an angle is opposite over hypotenuse, and cos of an angle is adjacent over hypotenuse. So sine 30 equals opposite, which is 1, over hypotenuse, which is 2. So sine 30 is half, and cos 30 is adjacent, so root 3 over hypotenuse over 2. So there we can work out sine 30 and cos 30. To do 60, we look at this angle instead. So sine 60 equals opposite over hypotenuse. So opposite is now root 3. hypotenuse is 2. And cos 60 adjacent, so the adjacent one is now 1 over hypotenuse, which is 2. So here we've got the values of sine 30, cos 30, sine 60 and cos 60. To do the 45 ones, we look at this triangle. So again, so sine theta is opposite over hypotenuse. So we pick one of these angles. Let's go here. So opposite is 1. So sine 45 equals 1 over hypotenuse. And cos 45 is adjacent over hypotenuse. So that's also 1 over root 2.